This lecture is on the definition and the making of solutions. What is a solution? A solution is a homogeneous mixture where one compound is dispersed throughout another compound, or defined slightly differently, a solution is a homogeneous mixture where one compound is dissolved in another compound. There are two terms we're going to use a lot. The first is the solute, which is the compound that is going to be dissolved, and the solvent, the compound which does the dissolving. If the solvent is water, we say it is an aqueous solution, and this is what we tend to use in chemistry. There are four general states of a solution. A saturated solution is when the maximum amount of solute, which can be dissolved in a given amount of solvent, is dissolved. If you add any more solute, it will not dissolve and will just usually float to the bottom of the container. The saturation point of a solution is frequently given in the unit grams per 100 milliliters. In an unsaturated solution, the maximum amount of solute has not been reached. If you add more solute, it will dissolve. In a supersaturated solution, this is an unusual case where more than the maximum amount of a solute can be dissolved at a given temperature. This is a metastable state and requires the input of energy. Lastly, there's totally miscible, and this is when there is no limit to the amount of solute which can be dissolved in the solvent. We will talk about concentration. Concentration is a description of how much solute is dissolved in the solvent. This can be qualitative, which is descriptive. We can talk about things being more or less dilute, more or less concentrated. We can use the ER, EST as suffixes, more or less. And there is quantitative. These are numerical values. There's mass percentage, which is the weight of the solute divided by the weight of the solution. Volume percentage, the volume of the solute divided by the volume of the solution. Mass by volume percentage, the weight of the solute divided by the volume of the solution. And molarity, which is moles per liter, and this is the unit that we tend to use in chemistry. So molarity, as I just mentioned, is the moles of solute dissolved per liter of solution. This allows us to standardize solutions, it allows us to calculate dilutions, and it's very useful in stoichiometric calculations when you have either an aqueous reagent or product, and we will be using it for this. So molarity is moles of solute divided by liters of solution. Note well, we're talking liters of solution, not liters of solvent. This is frequently rewritten as molarity equals moles per liter, which means when you rearrange it, molarity times liters equals moles, and liters equals moles divided by molarity. And we're going to do some problems to show you how each of these works. First problem. What is the molarity of a sodium chloride solution if 0.350 moles of sodium chloride is dissolved in enough water to make a 0.7 liter solution? Well, we know that molarity is moles divided by liters. We have 0.350 moles of the solute, the sodium chloride. The total solution is 0.7 liters. And when you do the math, you get 0.5 molarity, or 0.5 moles per liter, as the M and moles per liter are interchangeable. So now one for you to do. What is the molarity of a solution of sucrose if 56.48 grams of sucrose are mixed with enough water to make 450 milliliters of solution? Work the problem, come back, check your answer, and then we'll go through it. Go. The answer is 0.367 molar. How did we get that? Well, molarity equals moles divided by liters. The moles of the sucrose is equal to the grams of the sucrose divided by the molar mass, and that's 0.165 moles. The volume was given in milliliters, but we need to convert that to liters, so we divide by 1,000 and we get 0.4500 liters. Molarity is moles divided by liters, so 0.165 divided by 0.450. And that's 0.367 molarity. Next problem. How many moles of sodium hydrogen carbonate are dissolved in 250 milliliters of a 0.1 molar solution of sodium hydrogen carbonate? Once again, molarity equals moles divided by liters. We're looking for the moles, so we can rearrange the equation and get molarity times liters equals moles. The molarity is 0.100 molar. The volume is 250 milliliters. Convert that to liters by dividing it by 1,000. Plug it into the equation, and you get 0.0250 moles of sodium hydrogen carbonate are dissolved. One for you to do. How many grams of potassium hydroxide are in 1.25 liters of a 0.335 molar solution? Work the problem, come back and check your answer. Go. And the answer is 23.51 grams. We start with the basic equation, identify that we're looking for moles, and so we can rearrange. The molarity is 0.335 molar. The volume is 1.25 liters. Plug in the values, and we get 0.419 moles of potassium hydroxide are dissolved. But the question asks for grams. Moles times molar mass equals grams. Plug in the values, and you see that the answer is 23.51 grams. How many milliliters of a 1.75 molar solution of sodium oxalate are needed in order to have 0.125 moles of sodium oxalate? The basic equation. Now we're looking for volume, so we can rearrange. Liters equals moles divided by molarity. M equals 1.75 molar. Moles equals 0.125 moles. Plug in the values, do the math, and you get 0.0714 liters. But the question asks for milliliters. To convert from milliliters to liters, you multiply by 1,000, so 71.4 milliliters of the solution are required. One more for you to do. How many milliliters of a 0.5 molar solution of sodium hydroxide are needed in order to have 5 grams of sodium hydroxide in the container? Once again, stop, work it out, come back, and check your answer. Go. And the answer is 250 milliliters. We're looking for the volume, so we can rearrange, and liters equals moles divided by molarity. The molarity is 0.5 molar. To get the moles, we take the grams and divide by the molar mass, and you get 0.125 moles. Plug the values into the equation, and you get 0.250 liters as your answer. We need to convert to liters, so we're going to take the 2.50 liters and multiply by 1,000 milliliters per liter to get 250 milliliters. So to review, solution is a homogeneous mixture in which one compound is dissolved in another compound. The substance being dissolved is the solute. The substance doing the dissolving is the solvent. Solutions can be saturated. The maximum amount of solute is dissolved. Unsaturated, the maximum amount of solute is not dissolved. Supersaturated, more than the maximum amount of solute is dissolved, but this is a special case. And miscible, there is no maximum amount. Concentration is the ratio of solute to solvent. We will be using molarity, which is the ratio of moles to total amount of solution. M equals moles divided by liters. Note once again that the volume is liters of solution, not the liters of solvent. Since molarity equals moles divided by liters, the equation can be arranged, and molarity times liters equals moles, or liters equals moles over molarity.